Hello and welcome to my video, lesson 6.2, part B. This is permutations with repetition. So if we take a look at the word cell, S-E-L-L, we can see that if every letter was different based off the last video, we would be at 4 factorial, which is 24 options, because every letter can go in any one of the 4 spots, and that's it. But if we consider the idea that both L's are both the same, right? If we switch the order of those two, for example, cell and cell here, where L1 is first, or L1 is second, we can see that there's 2 versions of that word that look the same. So we have to remove the same options. And so what we're going to do is we're going to remove 2 factorial. Now, this is always going to be true. So if we take a look at this word, bubble has 3 B's in it. And so what we need to do now is recognize that there are 6 different options for the word bubble, where B1 is first, where it's in the middle, where it's last, and it's going to have 2 versions of each of those. So we have 6 total options. You can see them written out here. And again, this is going to be 3 factorial. So the point is, whatever number of items that are being repeated, we need to remove those options. So we're going to divide by that. Now, this is the formula we're going to use. It's n factorial over a factorial times b factorial times c factorial, etc., ... showing that this doesn't have to have 3 items in the denominator. It could have more, it could have less. But this formula is not in your formula sheet. So I recommend you just memorize this. You could understand the idea that I have written just above, saying we need to remove certain items based off the repetition, but I would just honestly just memorize this one. N factorial over a factorial, b factorial, c factorial. I call this the perm repetition formula. So if there are repeated items, we're going to divide by that amount. So let's go ahead and take a look at these different examples. Actually, I'm not going to do 5-letter arrangements. I'm just going to do distinguishable arrangements. So we're going to use all the letters in the word. So here we have the word physics. Physics, you can see, has an S and another S. Every other letter is unique. And there are a total of 7 letters. So 7 factorial over 2 factorial. 2 factorial is just 2 times 1 or just 2. So I'm just going to put that in like that. So it's 2,520. Okay, so now let's try another word. Let's try the word Star Wars. Now there's multiple things being repeated here. So we have 8 letters total. And we're going to see that there are 2 S's. So we're going to put 2 factorial on the bottom. But there's also 2 A's. So we're going to put another 2 factorial on the bottom. And there's 2 R's. So another 2 factorial on the bottom. So however many items that you have repeated, you have to list that many items on the bottom. Now, if we wanted to, we could include all of the letters, including the letter T, but it'd be 1 factorial. And as we know, dividing by 1 doesn't do anything. 1 factorial for the W, but again, those don't matter. So we're not going to include those usually, but technically, if you wanted to, you could. So it's 8 factorial over 2 factorial, 2 factorial. So it'll actually just be 7 factorial because the 2 times 2 times 2 is 8, and so it will cancel out with that 8. So 5,040. Okay, so those are classic questions, letter questions I like to call them, with repetition. And so what I recommend you do is every time you see a question, let's try to make it into a letter question. Letter questions are the simple version, so let's make everything we see into a letter question. So these are map questions. It talks about moving only down and to the right. We're always going from start to end. And how many different ways are there to get from start to end? Well, here we have to go to the right, down, down, down. At some point in this pathway, the person has to go right 2 times. We don't know the order, but at some point they have to go to the right twice. And they have to go down 3 times at some point. So I've just changed this into a letter question with 2 R's and 2 D's. So now we can make this 5 factorial over 3 factorial, 2 factorial. And I like these questions because they like to unzip as well. Based off our last video on factorial notation, we can unzip these. So the 3 factorial will cancel. The 2 will simplify with the 4, so it's actually 5 times 2. And so we get 10. All right, let's go ahead and pause the video there and try out the next question yourself. Okay, hopefully you were able to try it out. We're going to go ahead and do 3, 4 R's, and then we're going to go down twice. So it's going to be R, 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 D, D, just 2 D's. And so we're going to have 6 factorial over 4 factorial, 2 factorial, which is going to be 6 times 5 times 4 factorial over 2 factorial times 4 factorial. You're going to notice the 4's cancel, and the 2 actually will simplify the 6 a little bit. So it's 3 times 5, or 15. Now, this is not the only way to solve these questions. I'll go ahead and show you one more way of solving this, which is actually more interesting when we talk about combinations and the binomial theorem. But there is another way of solving this. So let's go ahead and think, how many different ways are there to get to this point? Well, it's just one. Like, it has to go straight down. How many to get here? Well, it's just one. It's just straight down. Here, it's just one. Here, it'd also be 1, but it'd be going straight to the right. Here, it'd also be 1. And then what we can do is we can add, I think, add the 2 positions to get to the next one. So this would be 2, because it's 1, or like it's going up to the right or down to the left. This one would be 3, because it'd be 2 positions to there, or this one. This would be 4. This would be 3, this would be 6, and this final position is 10. So it also can be done in both these 2 ways. So if you pause the video now, you should be able to get 15 on the second example. Okay, so let's go ahead and try this one. So there's 1, 1, 1, 1, 1, 1 to get to any of those corners. This is 2, 3, 4, 5. This is 3, 6, 10, 15. And again, it works just the same as before with 2 possible answers. I like to think about this as a letter question, but showing it the other way is kind of a cool way of looking at it as well. Okay. You know what I want to do? I want to do a more complicated example, but let's do that at the end. Let's go ahead and continue on with these examples first. Determine the number of different arrangements using all the letters of repetition if it must end with exactly 2 I's. Okay, so if it ends with 2 I's, what we're saying is, well, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But these two are locked in as an I and an I. But because it says exactly two I's, that means that this one cannot be an I. Not an I, right? So there were 10 options. Now there's 8 options, but it can't be an I, so now there's only 7 options. Then you can pick anywhere else, and I'll go this direction just because I started on that side, and we can count down. And so if it's exactly two I's, that's what we're showing here, which is 7 factorial times 7. So 35 to 80. As our answer. All right, let's try the next one here. It must end with at least two I's. Well, that's different. At least two I's means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That these two must be I's, that's fine. But this one could be an I. And because it could be an I, it could be an 8. It has 8 choices. Then 7, 6, 5, 4, 3, 2, 1. So this one is just 8 factorial. Oh, but I made a mistake. No, I didn't. This works just fine. There are different ways of doing this question, but this just works just fine. 8 factorial is 40,320. All right, here is one last question. If we have time, I might do one more after this. Doing different arrangements of the letters using all the letters of the word Saskatoon if the A's cannot be together. So what we're going to do is we're going to do it as if the A's are together and call that our unfavorable situation and put everything else. So S, K, T, O, N. So with the A's together, there are 1, 2, 3, 4, 5, 6, 7, 8 different items. And there are 2 S's and 2 O's. The A's are already together, so we've already dealt with that repetition there. So this is the unfavorable. What about the favorable, or the total outcomes? Well, the total outcomes is that there are 9 letters over 2 factorial, 2 factorial, 2 factorial. So this is the total. This is the unfavorable. What we want to do is we want to get the favorable. So we're going to go ahead and calculate this. So we're going to go 9 factorial over 2 times 2 times 2. We get an answer. We're going to do the same thing, but it's going to be 1 less 2 on the bottom and an 8 on top. And now we can take this number, the total, minus the unfavorable, and we get 35,280. So let's try one last sort of question. It's going to be another mapping question, but I want to show you guys a more complicated version of it. This is about as complicated as it can get. for a mapping question. And there's a reason why I like to do it as a letter question. I think it makes it make more sense. But it can be done either way. So here's a mapping question. We're going to go from start to end, and you have to move forward. And so what I'm going to do is I'm actually going to break this up into two different questions. And we're going to... Oh, no, I made a mistake here. I drew something slightly wrong. We're just going to go like this and fix that. There you go. That's what I wanted. We're going to draw this in two separate questions. So we're going to go first here. Okay. And then go here. And so you can see that this question has right, right, down, down for the first part. And yes, it is an and. It's right, 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 down, down, down for the second part. Then the second version of the question, or the second part, is or. It could be right, right, down, 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 and right, 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 down, down. And so what's really important is the words and or here. So this is an or between the two, but the blue part, it has an and there. And so for the blue part, we can now say, well, this is 4 factorial over 2 factorial, 2 factorial. And so it's multiplying. 7 factorial over 4 factorial, 3 factorial. The green part is 5 factorial over 3 factorial, 2 factorial. And so multiplying. 6 factorial over 4 factorial, 2 factorial. And then, because it's or, we're going to be adding those two together. So we can now plug this entire thing into our calculator. We're going to press enter, and our final answer is 360. So there's 360 ways to get from start to end. I hope this video helped you better understand the concept of permutations with repetition, especially the letter questions, which we can change other questions into. Hope the video helped, and good luck.